So we're going to look at two more quick examples of negation, and one of them actual number theory, believe it or not. So here's, they're both going to be negating quantifiers, statements involving quantifiers. So it is not the case that everyone loves cat videos. So we're taking the statement, everyone loves cat videos, and then we're negating that statement. We want to see what's equivalent to that. So someone might say, oh, okay, I'm just going to take this not, and I'm just going to put it in front of that verb there. We could say everyone doesn't love cat videos, or let's just translate that to everyone hates. That's not exactly the negation, but let's be rough. Everyone hates cat videos. Okay. It's not the same thing. This is not the negation of the statement. All I'm saying is it is not the case that everybody loves cat videos. That doesn't mean the other extreme that everyone hates cat videos. This is a very, very common example of a pitfall. And if you're focusing on it, people tend not to get it wrong. But it's when you don't focus on it that it's very easy to get this wrong. And I see that a lot in logic and like probability and things like that. Okay, so what's in between? It's not true that the only possibility is that everyone loves them, or everyone hates them, or everyone doesn't love cat videos. Okay, so this is not the correct negation. Okay, instead, if it's not true that everyone does something, all that has to happen is that there needs to be one counterexample, one example of someone not loving videos. And so it's very similar to what we had before. Moving a not through an or an and switches it to the other one. And moving a not through an every, that's implicitly a for every, we'll write this in more logical, symbolic logic notation in a minute, that changes it into a there exists. There is someone, some poor unfortunate soul, who doesn't love cat videos. Now, we still have to deal with a little bit of a natural language thing. You might interpret this as a statement, there is exactly one person who doesn't love cat videos. That's not mathematical interpretation of this. This says there is someone, and there might be another, and another, and another. There might be many. In fact, it might actually be true that everyone hates cat videos, that nobody loves them, that everyone doesn't love them. But the there is someone just means there's at least one. So we could say at least one. At least one person. Okay, that is the correct negation of the original statement, everyone loves cat videos. So you could say for every person, the original statement in brackets was for every person X, X loves cat videos. To negate that, sometimes you put like a tilde in front of something to negate it. Okay, that turns into there exists a person X such that, I'm going to abbreviate that as ST usually, such that X doesn't love, getting a little cramped for space here, doesn't love cat videos. The negation of a for every turns into a there exist. And so the not kind of migrates through. You have the negation, it doesn't go away. But as it migrates through, it turns the for every into a there exist. Same thing, if you negate it into there exist, it turns into for every. Let me actually show you that in the next one with a more number theoretic statement relating to some of the stuff we were doing before. Here's a true statement. Let's say this is statement 3. Make sure my marker isn't backwards. It's not the case that's what the little tilde is a nice very shorthand for. It is not the case that there is a rational number, say y, such that y squared equals 2. So here's the statement that we're negating. And the reason we want to negate this one is this is a false statement. This is the assertion there is a rational number y such that y squared equals 2. That's the assertion that the square root of 2 is rational. We know that's not true. So we want to negate that. Okay. Well, what's an equivalent way to say that? Okay. So again, the false one would be there is the inequivalent way, there is a y, and let me just abbreviate it a little bit more. There is a y, it's a rational number, such that y squared is not equal to 2. Now that's a true statement, but it's a lot weaker than saying that the square root of 2 is irrational. This just says there are some rationals that don't square root of 2. Well, you don't have to go through any kind of proof about the irrationality of 2 to realize, hey, 0 squared is not 2, and 5 squared is not 2, and a million squared is not 2. This is true, but it's not equivalent to this much more profound true statement up here, that it is not the case that there is a rational number. So this is not what we were looking for, not because it's false, but because it's not logically equivalent to that guy. The logical equivalent here is when you negate that there exists, it turns into for every. So let me do it in logical notation. Let me translate this one. It's not the case that there exists y in Q such that y squared equals 2. You start to really appreciate the symbolism when instead of writing all this stuff out. So, okay, so really the translation of this is that for every y in Q, if it's not the case that there is any example, that means that for any rational number you pick, it is not an example of this statement, y squared. Okay. So this one, the one that wasn't equivalent, would have been there exist in symbols. It would have been there exists y squared not equal to 2. A super weak statement. True, but incredibly weak. This is a much stronger statement and much more interesting. No matter what rational number you pick, if you square it, you will not get 2 because the square root of 2 is irrational. Okay. So this is an example of negating a there exists, and when that negation comes in here, we could even write this as it is not the case that y squared equals 2 if we wanted to. Okay. When you bring the not through, when it sort of moves, I picture it kind of moving in, and as it moves through, it switches this there exists to a for every. It's a very, very typical thing.